Okay, so like I was saying, before we had a break, so I said there's typically no certification in tech you have that you're not going to learn something a little bit about security, about cloud, about IoT, because that is like the new thing. So especially if you're not doing networking, so cloud is an extension of networks. IoT devices is an extension of network. Cisco used to have a IoT security certification. I have it. It's more than, it's quite some years now. So you see, IoT is what we call Internet of Things. So Internet of Things is that you're saying you have things, you have devices, you have telephones, you have doors, you have AC, you have your car, you have your fridge, you have your freezer, you have cameras, you have things, you just have devices, you have items, and you want to be able to control them over the internet. You want to be able to use them over the internet. You're able to do typically control, right? So all of those different types of devices you're going to have, how do you manage them? So once you're doing that, you're typically having an interconnected system where you have different devices, right? Somebody, okay, good. So somebody said, is CCTV, IP camera, and IoT? Yes, once you can control it over the internet. Now, since it's an IP camera, if it's going to be enabled, then you cannot say it's an IoT, right? It's an Internet of Things, because you can control that particular camera. You can view the footage from that camera over the internet. So for that to happen, at times when I tell security students to go learn CCTV camera installation, the device, the DVR, the NVR, how to do your backup and whatever, some of them say, why am I going to learn? You can't talk about security without or you can't talk about tech without security. Then you can't talk about security without talking about physical security. So just like we say, if you have the best system, the best network, or the best solution to protect your infrastructure, and it's not secure, you don't have, because one disadvantage is that somebody can cause business discontinuity. Somebody can make sure that you are not operational. The person might not be interested in stealing your data or maybe causing problem for someone. No, the person just wants, maybe the person is a competitor, is a rival. He wants to make sure that you are not delivering service. And one way to do that is to pick up your digital asset. So that's why physical security is very, very core, very, very integral to you having a good IT infrastructure. So if you set up devices, your networks, you secure them, one way to do that is through physical security. And physical security, that's where you have your access control, you have your doors, you have your cameras. Okay, so let me write it. So cloud. So cloud is an extension of a network. So cloud is just saying, how do we just have the things we typically have with us, our PCs, then our networks, then our softwares, like our Microsoft Word, our browsers, our internet resource, our applications. Maybe I'm an accountant, my Sage, maybe let's say I'm a data engineer, my SQL or anything I'm going to use to plot graphs and whatever. How am I able to do that without physically having those things? So in cloud, there's what we call CapEx and OpEx. Let me just write. Right. So we say in cloud, we say OpEx versus CapEx. So it's a capital expense versus operational expense. So if I need to set up a server, physical server, or if I need to buy one, that is CapEx, capital expenses. I'm going to spend money to configure. I need to even get details of what type of server. And if peradventure it doesn't now serve my purpose. I have to sell it off and buy a new one. I have to do backup. So all of those issues you're not going to have if you migrate to the cloud. That is where OpEx comes in. So you just pay for operations. You just pay for 1 or 2 persons that's going to help you manage your system. Take, for instance, you want to buy 3 terabytes of drive space. That is storage, right? Storage. So because in cloud, we talk about processors, processing power, storage power, computing power, software power, platform power. So we're trying to say in cloud, we just need to get a vendor like AWS, Azure, or Microsoft, or Alibaba, or Cloudflare, or different types of cloud platforms that provide either security, softwares, platforms, and whatever. And we just pay a small amount, operational amount per month. And we have that. The Google Drive, you could pay for 3 terabytes, 1 terabyte with a small token every month. But if you want to go and it's readily available to anybody anywhere in the world, you can share your items on Google Drive. But if you need to have a physical server or physical file server or physical system, then you provide security for it, then make it available on the internet. Maybe people will now VPN into it and wherever. And the knowledge to even set up that is what we call CapEx. So the capital expense is quite huge, and that is what the cloud solves. And to do that, for instance, networking comes into play. So like I said, that's why you can't talk about networking, you can't talk about tech without mentioning security, cloud, and IoT. Then, of course, troubleshooting, because the certification is Cisco Certified Support Technician. So you are to solve your like first line. If people have problems, I have issues with, like somebody I interviewed in the office this morning. Somebody have issue with the system, his mobile app, with his printer, with his any of these gadgets and wherever, they have to help him deliver service. Anything technology-wise, you're going to be the one that is going to help him fix the issue. So those are the kind of things we're going to be looking at in troubleshooting. Okay, let's get to business. So most of these things here are like the explainer that I did in the very first intro. Okay, so these are questions, assessment questions. So let's get to internet networking. So a network is typically, like I always say, you having, it can be 2 phones, it can be 1 phone and a printer, it can be a printer and a phone, it can be 2 printers, 1 laptop and a switch, 2 routers, 2 laptops, 1 phone. Once you have more than a device and their goal is to share resource, and the resources can be file, it can be hard drives, it can be printers, it can be CD drive, it can be internet, it can be anything, you have a network, right? So this module is about identifying the conceptual building blocks of network. And I also want to encourage us, like I said, on the channel, I will drop it maybe after today's class or tomorrow. I did a complete record on ITA, Introduction to Networking by Cisco. I also did a complete record on ITE, that is Information Technology Essentials. Please use those 2 guys as a backup for your learning. It's going to make it, most of these things I've explained them, but in a slide format. I don't want to repeat slides here, so that's why I'm just picking the most important concepts and explaining them and give break room so that if you have questions, you can ask. So Cisco over time have had so many certifications, so you're going to see overlap of knowledge base. So if you use 1 or 2 certification or 1 or 2 materials to learn, it will make the exams very, very easy for you, and something you're going to pass without issues. So here we're also going to be talking about OSI model, frames, packets, and of course, addressing. So networking have changed over the years, and if we need to deliver service, we need to set up a network. Before, people typically can't set up their own networks. They will need network engineers. Now, the demand for that have gone down over the years, but that demand is still there, especially for large-scale enterprises. But for small-scale enterprises and small businesses, they will typically don't need a network engineer. They'll typically just get a support staff from a bigger ISP and say, please come help me deploy a network, or come help me bring a router, maybe put a radio. A radio is something like this. So I'm going to have a point-to-point radio. Let's say Microtik or Ubiquiti. And what is going to happen is that if I have a mast near my house, the ISP is going to check which do they have license for. And they're going to pick this radio. They are now going to connect it to, let me use, which example am I going to use? Okay, let's use this particular one. So something like this. So this radio is going to be facing, this is an Ubiquiti radio. It's going to be facing a particular mast, maybe something like something like this. So you see, this is my house. My house is somewhere here. This is a small business. They just have what we call a CPE, consumer premise equipment, right? So that's what we call it, a CPE. So you can refer to these radios as CPEs. These guys that you mount on top of a roof, they'll be connected to a mast. Then from this radio, the way it is, you now connect it down to a router. Then everybody in the office cannot connect it to that router. You can also take it to a switch. Everybody can connect to a switch. We understand what a switch is, what a router is, if you don't know. So these small businesses, most of them will just call the support engineer from the ISP, come to my house, come to my home, buy the entire kit, to just set it up, and that's all. If they have issues once in 2 months or once in 3 months, even if you have 50 people in this building, they just call them maybe on retainer or on need basis. They won't typically need a network engineer here. But you see this company, or where you're going to have a very large corporate building where the nodes on the network is quite much, you just got to have a support technician on the ground, because you cannot be calling these guys for every little thing because of the number of systems, right? So, these needs have grown, but it has adapted to how people will typically need these services. So you can't actually say a network engineer is not going to be useful. So that's what I've also told some students, some persons, a very nice adaptation to your networking skill is to work for an ISP, is to be an ISP distributor or a marketer to implement in homes and offices, is to start doing networking in the cloud, is to start, there are several associated things you could do with a networking background. Okay, but for a very small business of less than 20 persons, they will typically not need somebody they're going to employ full-time, except it's going to be on retainer. So you can also do provide first-line support to different businesses. So typically you freelance to help them support their IT needs. Of course, because we're talking about network, so that's why you reselling for maybe 1 or 2 ISPs is going to not make a lot of sense, because people want better internet at home, so maybe expand the network they have and all of that. Okay, so there's what we call network segmentation. So network segmentation is an important aspect, one, to help us grow our network so that our network can become big. It's also very important because we want to provide security. So network segmentation helps us to secure our network. Imagine if I have networks segmentation. If I have a building, let's say a bank, and I don't segment the network, there's a lot of things that can go wrong. You can pause your video and let me know what can go wrong. I'm listening. If you don't segment your network in a building of, let's say, 200 pieces, what can go wrong? Let me know. Question time. I need answers. Questions, I need answers. So one beautiful reason why you need network segmentation is for planning, is for troubleshooting, is for security. The advantages are so numerous, because look at, if this is my CPE, or my CPE is here connected to a router now, but everybody is not just connected to this guy. It's just going to be coerced. So we now say, okay, general persons, just like if you go to the bank. If you go to the bank, you don't just get to see everything. If you are told you can connect to this to be able to do one or two things, you don't get to from there have access to every other thing. No, that part is a segment. So there can even be a control. If you segment a network, you can even do better access control. And access control is tied to better management, is tied towards security. So most of these concepts, you get to get them clearer as you move on. Now look at general. So everybody maybe just here, maybe general room, PCI network. I wouldn't know what they mean by this PCI, maybe personal something. I don't get this diagram, this high vision. Then here is for video surveillance, because I'm trying to record my cameras, put them on the network video recorder. There's a router here that can give me access to the internet, and of course it's firewall so that people cannot use showdown, use some security tools to like tap into my router and see what's happening within my enterprise if those cameras have vulnerabilities. I can have another section that's going to be for the managers. I can have another section that's going to be for staff. I have another section that's going to be for tech, IT. So that way, if like a student said, he says that for better troubleshooting, if I have a problem here, it's here, right? So which router is this tablet connected to here? So I try from here to ping here. Can I get results? If the answer is yes, can I get results? Answer is yes. That means the issue is from here. We're going to learn about troubleshooting later on. Okay, somebody else is saying something. There won't be load balancing. Network might be slow. Segmentation also provides a more or less layer of defense. Okay, good. So here we have defense. Gideon is saying defense, security, load balancing. Of course, if you were doing Cisco routing, switching, wireless essential, that's CCNA2. Or if you're doing CCNA proper, because that's beyond the scope of this course. So you learn about in CCNA, you learn about load balancing, quality of service. In CCNA2, you learn about sorry again, let me check. What was the students mentioning again? Okay, load balancing. Okay, we could refer to that as it's still considered maybe CCNA3. So in load balance, we're trying to say, okay, if our ISP gave us 100 MB per second, we can share and say we have a management PC here that is connected to the server or the room. It's connected to the room. And so we say, we use a tool like Microtik or Meraki, and we say, please, this router, this IP address, you cannot do more than 30 MB per second. So everybody here is going to share MB per second, 30 MB per second. Everybody here, 30 MB per second. Everybody here, 30 MB per second. Management, 10 MB per second. So we've shared and we've load balanced, right? Or we've like, whatever load back and forth, up and down that we are sending, we've actually made it possible that somebody cannot do more than somebody else. Or if we need maybe TCP, or let's say port 80 to be able to have more access, to be able to download something or upload something, all of those kind of access control, load balancing, it's possible, or we can have a second router here and allow that guy to be able to manage some other things. So it's always good, it's a very good practice to segment your network. You see, a better way to do this network is everybody here just connect to this guy. It's going to be far cheaper. I was telling somebody some few years ago, you want to set up a network, somebody gives you a quote. It's very cheap. Another person gives you a quote. It's more expensive. You should be asking, why is this one more expensive than this guy? So look at how he wants to implement the network. Look at this guy is now going to be buying this router, he's going to implement a switch, he's going to be implementing another router. Ordinarily, all of these guys should be able to connect directly to this router. But it's not doing that. He's going to buy 1, 2, this might be software or hardware depending, 1, 2, 3, 4 extra devices, and this can inflate the fee by maybe, let's say, $1,500 or $2,000, and the equivalent depending on your country. Okay, so let's move on. Anybody have questions with respect to segmentation? What is segmentation and why it is important? Anybody have questions with respect to that before we move on? Okay, if you ask your question, I will see it on the chat. Let me write down. Now, routers, switches, bridges, hubs. So we will get to understand them as we move on in the training because it's explained. So for your network, you need to be able to differentiate, or for your exam, you should be able to differentiate what is a hub, what is a switch, what is a router, what is a bridge, and at what layer are they on. Right? So we'll look at them as we move on. Now, LAN. LAN is a local area network. So a LAN is typically, I want to be able to have few systems and maybe a switch. That's what they call a LAN. So one thing you're going to be wanting to do if you are setting up a LAN is that you don't want too many hosts. And that's one good thing why you do segmentation. You don't want too many hosts in one collision of broadcast domain. Like for a switch, it's going to be like one broadcast domain, because when we say broadcast, when you send out your information, right? There's another, let's use this for example. If you send out this information, this is one broadcast domain. So if I send out, every other person on the network is going to receive. But if I segment and do access control, if I send and this guy is here, it will just come to this guy. It wouldn't need to go and transmit to other devices, other items I have on my network. So that's one disadvantage of, or one thing that can happen if you have LAN congestion. You have low bandwidth, because imagine everybody trying to get messages. It's like talking to 100 persons when the message is just meant for one person by your side. So what's going to happen is that you're going to expend more energy, and that's how it is when you have congestion, because you're going to use a lot of your bandwidth. Okay, and several other reasons. Another concept here is WAN. So a WAN is where you have more than one LAN, right? And when you have more than one LAN, the way to interconnect them is to use a router. And that is one excellent definition of a router. A router connects more than one network together, or a network helps to route traffic from one network to the other. That's why the router, as it is here, this guy can ping this guy. This guy can ping this guy. If this is a switch and this is a switch, it's never going to be possible if they are separate or in different network. The only way that can be possible is if I'm going to have a router in between them. So if I say a WAN and I switch to my images, you see, I'm going to be saying something like, at times we call it a wide area network, right? Something like this, right? So you see a LAN, a LAN, a LAN, a LAN. It be connected over the internet. And when you say internet, what's going to take you out of the internet? It's what? Is a router. So this is a symbol for a router. This is a symbol for a switch. If you are reading stuff online and the rest, Cisco uses this convention very well. And in this course, you're going to be learning a lot of packet tracer. So you're going to see that when you refer to one, now you're saying, okay, you have many of these LANs connected together. Hope that makes sense. Okay. 2 advantages of using routers in your network. Good, excellent. So a router is going to do a better work compared to a switch. Okay, why? Because a switch, like I said, though it's more intelligent than a hub, but cannot route your traffic. If you connect your laptop to a switch now, let me just get an image for you. So let's say you say a LAN, right? So a LAN is just, at times a LAN can also have a router, depending. Let's say you have a LAN, something like this. So I have system 1, 2, 3, 4, 5, 6 with a switch. These guys cannot move to, let's say, UK or US. They cannot get to another part of the world. They cannot ping maybe a system or upload something to a server or whatever. It's just local, typically going to be within a building, right? So, the duty of a switch is just to expand your network. I have these 2 systems. If I want to connect them, I can put a cable, Ethernet cable between them, and they can see themselves. Or I can do Wi-Fi, or I can do peer-to-peer, right? But if I need to extend it to more than 1 devices, I pick up a switch. So switch typically just forward packets between devices or extends your network, whatever definition or stuff you want to use. Now, but what a router is going to do is that I'm not going to add a router here. So all the traffic here, push to this router cannot get me out of this area. And that's why we say a router is more intelligent. A router is going to do better packet filtering, better switching, path selection, internetwork communication, because it's only a router that can get me out of this network. Simple. You have a phone, you have a router at home, you want to connect to the world, you connect your phone to the router and the router sends you out of the network. You have something you want to connect to your office, and your office gave you a VPN access. How are you going to do it without internet? And what provides internet for you, to you, a router? Funny enough, your phone routes traffic, right? So that's why you can use your phone via DHCP. You can use your phone and share like you kind of network to be able to provide multiple persons access to the internet or access to other networks. Okay, so these are some of the reasons why you bring in a router. Okay, also understand that a router is layer 3. So when I talk about the OSI model, I will explain that in more detail. Okay, so this is what I was explaining, interconnecting devices. So you see, I have a switch, I have a switch, I have a system, I have a switch, I have a switch. I have no, this is I think this should be a hub or so, if I'm not mistaken. Okay, yeah, it's a hub, yes. This might be call them maybe one controller, or maybe still a hub, because each of these dash, they all have their symbols. So this is a hub, this is a switch, this is a router. A router is always like a star symbol. This is a bridge. Now, so this is what we call an interconnected network. So, of course, this guy is going to be the guy to send us out of the our network. Same thing applies here. You have a switch systems, a major switch. It can be a layer 2, layer 3 switch. I will explain that later on. Then you have a router. It takes your traffic out of the network. Okay, so there's something I'm going to give you as an assignment. I think I'm going to type an assignment here. So just take note of it. So I'll type an assignment here. Assignment. Use Google or GPT, and differentiate in a tabular format. LAN 1. I think there's PAN also, right? And that's it. So take this down and let's have your answers on the group. Now, let's talk about the OSI model. Now, because we want to connect, we want to look at more than one system, two systems need to connect. The question now is that how are they going to, can we have like a standard, right? So the OSI model, which is Open System Interconnect, is just a reference model. It's just to say, if two systems have to communicate with each other, can we have the kind of like a standard? So that if somebody is building a software, a hardware, a router, a switch, a LAN card, all of this kind of stuff, people stick to standards. Okay, somebody is asking, somebody have a question? Just a moment. Somebody says, okay, what's the difference between hub and switch? What's the difference between hub and switch? There's the span. Drop the assignment on the group too. Okay, so I'm not be dropping all of the things I'm saying in class. So please get a pen or your phone and drop it in your maybe notepad on your phone so that you don't lose track of anything. But because I have these notes, if you miss the assignment, I'm always going to ask for it. So switches, router, hub, I think I've explained already. So a hub is not as intelligent as a switch. A hub is just like a junction box to like share packets or forward packets. So it's not intelligent. It does not do traffic control. So that's why back in the days, most of those hubs, if you have them on a network, you typically have to restart the hub every period of time because most of those systems, they will lose track, they might not be connected again and all of those. Those are the issues you had with hubs, right? Switch came up and Switch had more intelligence in the sense that with switches, you can do VLANs, you could do segmentation, you could do, if I send a packet to a particular system with a MAC address, it knows where to send it to. So it's like it's a T-junction with a traffic light. But a hub is like a T-junction without the traffic light. So everybody just moving, right? Whereas a router is going to do a better intelligent job and not just forwarding packets, but it will do filtering. That's why in a router, you can see that most routers these days, you could say, okay, I don't want you guys to be able to access so IP address. I don't want you guys to be able to access what's it called? Websites. On most routers you have these days, you could do access control, right? Just go to the router, go to the settings, go to access control, or go to URL filtering or whatever. You could say, okay, no Facebook, no Twitter, no Instagram, no YouTube. And people, once you're on that network, you cannot access those sites. So that is a very intelligent thing that what's it called? That is a router can do that a switch cannot do, right? So very, very clear. Hope you got that clear. Okay. So I was talking about OSI, interoperability, operate. So how can more than one device, how can more than one vendor be able to interoperate? So that cannot be possible if there's no standard. So the OSI gives us an excellent standard for that. Okay, so we call it a layered approach. So it's a way you have, just a moment, please. So in the OSI model, we're just trying to say, how do we make sure that whatever vendor that we have, they stick to standard, right? Like I said, you can have your router vendor, your switch vendor, you have your Ethernet cable, your Ethernet not cables, in your internet port, you have your Ethernet adapter, the cards, because that's the guy that comes with the MAC address. That's the physical address. All of those things. So we need a standard so that we can understand how systems connect together, right? So it's always what we call a layered approach. So we have sorry, just a moment. So we have application, presentation, session, transport, network, data link, physical. I know everybody here, you must have seen this stuff before. So it's called the OSI model. Okay, so this is the OSI model. So we typically say, for me, my mnemonic is going to be, please do not take sweet potatoes alone, because of course I love sweet potatoes. So if you are eating sweet potatoes, make sure you call me. Please do not take sweet potatoes alone. The layers are 1, 2, 3, 4, 5, 6, 7. You count from down up. Don't say layer 1, 7, please. Or layer 2. No, it's physical, data link, network, transport, session, presentation, application. And what we're just trying to say is that if I have, this is a system, okay, let me get, okay, good. Let me use this. A second, let it load up. So what we're trying to say is that if I have two systems, this is good, awesome. This is client side, this is server side, or this is system 1, this is system 2, and they want to communicate. All we are saying is that at layer 7 is the application layer. They might be using Chrome, Opera, Outlook, Microsoft Word, or Google Drive, Microsoft file, and whatever. It can be any application. The only way this guy at this end is going to be able to see, this guy at this end is going to see this application or see the files or the whatever, is by him opening his own version of the application to be able to read this particular file. But the point is that the data does not get to him just like that. It comes down like this, gets to the wire, physical, gets to his own network, his cables, his switches, his router, like that. He opens it up and he reads. Does that make sense? So we're just trying to say, this is a model. This is like a pattern through which two systems, two servers, a client and a server, can actually communicate. And we want to understand what is happening across each layer, down and up. And down this way, we normally say data encapsulation. And up this way, we say data de-encapsulation. Because what happens is that if I have a parcel, like if I want to write my address, I want to send you a letter. The boss, I want to send a letter to the king. I want him to send the security guys to come protect me. I'm going to say, my name is this. I will now put maybe my address. I'll put my state. I'll put my country. I put my region. I put my continent. Maybe one other thing here. Once this stuff goes, it's already addressed like a letter. It will open up. What's the continent? Like the postal office guy. What's the continent? It will segment all the different continents. What's the country? It's now de-encapsulating. At this point, it was encapsulating. It was like adding data, adding information to the item, to the data. Here, it start opening up like an onion. Start opening until it gets that particular message, which is simply, please get me guys, security guys, to come protect me. So the OSI model just tells us how data goes between both sides and what is happening at each layer. Okay, back to this image. So at the physical layer, which is your physical structures, your coaxial cable, your fiber optic cable, your wireless cable, your hubs, your repeaters. Whereas at the data link layer, that's where you have your bridge, you have your switch, you have your PPP, you have your Ethernet, you have your frames. At network, that's where you have your packets, your IP, your ICMP, your IPsec, your IGMP, your routers. At transport is where you're going to be having all of that like that. So your goal for the exam and basics of networking is that you want to actually understand what happens at each layer. And that also gave, I think, an additional assignment somewhere here. And I say discuss the OSI model as it refers to how interconnected devices can better communicate. The reason why you want to have the OSI model, or why we have the OSI model, is so that two systems can communicate. So without the OSI model, there will not be a rule, there will not be a guide. Take, for instance, when you have presentation, for instance. So here in presenting the data to this guy, we're saying, how is that data going to be presented? Is it going to be secured? Is it going to be SSL? Is it going to be secure socket layer? Is it going to be SSH? IMAP is email. FTP is going to be file transfer. MPEG, this video, this picture. So how do we represent that data? So at the very first point the data is coming in, it goes, this is the user layer, end user layer. It goes down like that, goes through your wire, on your stuff, it leaves. Then the other person at the other end opens it up. So I want to do a very small research and look at how the OSI helps us to better communicate. Okay, we have a question with respect to the OSI model. And so you have some description here in the guide. Application, provide the user interface. Presentation tells us how data is going to be presented, like encryption, like video. Session keeps different application data separate. Think about your banking app. Think about your browsing session. So a session is just typically a period between two scenarios or two instances. If you log into your banking app, what's going to happen is that after a certain time, if you don't have constant activity, that session, that time lapse is going to expire, right? So if you don't have activities, that particular session, that particular period of time, that particular time lapse is going to be recorded as a session. It's going to have what we call a session ID, right? So that we can identify all of the different things you did at that period, right? With that particular session ID, right? So that's what a session is also very, very important concept in security, because if our applications don't have session, it then means that we cannot tell what happened, how it happened, what made it happen, what are the kind of things the person did. I think when we consider security, we'll explain this a little bit more. Then in transport, we're saying, how should it be transmitted? How should it be transferred? That's where TCP and UDP comes in, right? So I think we learned that in module 2, in the chapter 2 of this particular training. That's where we're going to break down most of these. So you just see that the entire CCST is actually the OSI model. You're learning about the OSI model, because that is the very heart of networking. So if you understand that, everything you're going to learn, whether it's quality of service, whether it's what's it called, different kind of protocols for small business, OSPF, BGP, border protocols, large-scale enterprises, is all hinged on how how data is going to move with respect to the different layers. Then, so of course, in transport layer, so you talk about connection and connectionless transactions and the rest. So when we say connectionless, I think it's somewhere later on in the chapter, we will consider it. So here, I just want you to be able to understand the OSI model, understand what each layer does. I might make a separate short video, or when you guys do your assignment, this particular assignment, I can now use the case studies to, okay, let me add to this, discuss with case studies, please. I can now use the case studies to like do you more explanation. Okay, but for now, know the layers, know what they represent, know how to know what is layer 1, what is layer 2, what is layer 3, and the rest, and that'll be fine. So this is now explanation of each of the layers. Application layer, what it does, because that's where you have your browsers, you have your softwares and the rest, right? So one good thing also you can do, you can say OSI model, protocols, applications, right? Let me see if I can get something for you. Okay, this is awesome. I think I'll drop this for you guys in the, let it load up. I'll drop this guy for, just drop this for you guys in the group, this particular one. No, let me look for something better. Okay, so are you seeing? If you can see my screen, let me know, please. If you have a question with respect to protocol, what a protocol is, please, you can drop in the chat. Now, to save time, a protocol is just a means to communicate, like a line of communication, right? How do we establish communication? Take, for instance, I can tell you guys that, okay, like one of the things I did in the first class, and even in the beginning of this class, is to tell you the class protocol, the class rules. The class rules is that we're going to have 3 classes in a week, and those 3 classes, the 3 of them are going to be live Zoom classes, and after that, we're going to have live, what's it called? We're going to have live lab sessions. Then we're going to have like 5 classes live, about 2 or 3 or so is going to be recorded. Then you're going to be in a WhatsApp group, and it's going to be always open. You can ask your questions. So it's a protocol. So I don't expect now any of the students now say, okay, I have an issue with transport layer. How do I differentiate between TCP and UDP? And you send me an inbox. So you are going against the protocol. So what should you have done? You should have gone to the group and say, okay, I have a question on this and this, because the protocol is that you use the group. The protocol now is not for us to use slides to train. Neither is the protocol for us to, let's say for an exam, the protocol for an exam can be CBT, OBJ. That's the protocol. So you don't go to the exam and expect a theoretical question. And that's how it is in networking. So when we say TCP, HTTP, HTTP is a TCP, is a connection-based type of protocol, right? DNS, for instance, is UDP. Okay, so you have several types of connections. I think we're going to see this in module 2 of the training. So if you want to go a little bit ahead, you could just say, TCP versus versus UDP port numbers and application. You could put this in Google, you could put this in what's it called, in ChatGPT or any software that you like. It's going to tell you each of the protocol, the port numbers rather, the protocols, and how they are applied. Very critical. You should know at your fingertips top 10, 15 port numbers, the protocol, then how it's being used, right? So you should know that, okay, 20 is TCP, is connection based, and it's used for file transfer, right? 21 also, 22 also, that way. And you should know their common usage. By the time you learn that way, it's faster for you to understand, it's faster for you to be able to differentiate most of these things. Okay, like I said, if you have questions, I'll draw some of these images for you on the group. You can ask. Take, for instance, 443 is TCP, is what? Is HTTPS. Okay, so for the transport layer, you want to be able to differentiate between TCP and UDP and tell us where they are applied, their application. Of course, these are the different applications for each of the port numbers protocol. So we're just saying in communication that anytime I'm using port 23, it is TCP, it's telnet. Anytime I'm using, if I want to do a secured file transfer, port 22 is also what? Connection based, is what? SSH. Anytime I'm using port 21, it's still TCP, but it's not secured, just regular FTP. So you should be able to understand most of these things. Make your notes and know them for your exams. Okay, so when we say connection-based kind of protocol, what do we mean? I should be ending this session in the next 5-10 minutes. What we're trying to say is that there's going to be a three-way handshake. It then means that if I want to speak to you, let's say Akin or Francis or any of the students, I can't just say, I can't meet you in the office, or I can't just call you on the phone and just say, please, I need $10,000. I can't say that. I have to say, hello, are you there? Are you hearing me? How's today? Hope today is fine. You reply. Then I say, okay, please, I need a loan of $10,000. I'm going to pay back in 2 weeks. You're not going to say, okay, I might not be able to do it today, but I think before the week runs out, I'll send it to you. Please just send me your account number. And we have conversed. Same things on the streets. If you go to the streets, you can't make a request from somebody just like that. You just have to say, hello, good day, man. My name is Victor. Do you know where I can get to Southtech? Is it on this street? You cannot even make that request first. You even have to first greet. There must be a response. It then means there must be a sync, a synchronize. There must be an acknowledgement of the synchronization. Then there cannot be an acknowledgement. That's to say, hello, good afternoon, ma. The person replies, fine, how's today, what's happening? You now say, fine. You acknowledge. Then that connection is established. You cannot say, please, I am looking for Southtech on this street. You can't just meet the person and say, Southtech on the street. The person is going to say, what's wrong with this guy? Why? There's some kind of conversation that's going to happen. There's some kind of transfer of data that's going to happen. You can't have them without first establishing connection. So that's why we call them connection-based protocols. And these are the examples. So all the ones you see, TCP, 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 they're all what? Connection-based. The ones you see, UDP, 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 they're not connection-based. Take, for instance, DNS. DNS is, I think, for 53 thereabout. Where is it? Yes. It's not connection-based. And there are times that it can be connection-based. It's not. Some of them have one or two. But DNS are the most of the times when it comes to querying the domain name server of a particular domain, either Active Directory or let's say a, what's it called, a web application or whatever, it's going to be mostly UDP. So you don't need a response from that server to now know what the DNS server is. Same with, for instance, in voice over IP, in video streaming, those protocols are UDP, right? They are connectionless. They are not connected. So let's say if I want to do a voice over IP phone call and wherever, I don't have to call first to now know if you are there before I can transmit and wherever. I just make the call. So there can be failure, there can be call drop, right? And several other things can happen. So normally I always tell students, don't say there's an advantage of connection based and there's a disadvantage of non-connection based protocols. Just put it that each type of protocol have its best application. That's how you're going to look at it, right? Take, for instance, if you are doing streaming now, streaming we have something like buffer to take care of any lag, right? So you cannot do streaming with what's it called, TCP, because TCP have to establish connection first before it will send a packet. That means if there's a delay at the other end, it will cut it and reinitiate it again. Okay. So if you have questions with respect to connection and non-connection based transactions and wherever, you let me know. So there are some kind of flags. They're not in this book, but I just added them: reset, push, urgent, sync, acknowledge. But the one you normally see is acknowledge and sync. If I am browsing now, and I'm typically going to send a sync, my ISP or my router will send me a sync arc and whatever. Then if it's established, I can now browse that website. Now, depending in quality of service, or if you are managing your network using Meraki or using Microtik or any software, you can say, okay, this particular protocol, I want to prioritize it, right? I want to prioritize it. So I want to prioritize FTP. It then means that in the queue, FTP will get more bandwidth, FTP will do more stuff. And of course, we have push, then we have reset. Reset most of the times happens when, let's say if I want to access something and it does not work, the reset flag is sent so that transmission cannot be restarted. So most of the time, all of these things happen in split seconds. If I'm trying to browse a website and it's rolling, while it is rolling, it can reset like 2 times before it returns a message and says website not available, right? Okay, flow control is a very important concept I want you to look at. Okay, what else again? Okay, so this is data link layer. I think this is the second layer. This layer 2. So another word for what's it called? For MAC address is physical address. So please note that. Another word for another name for MAC address is physical address, because this is the data link layer is where you have the MAC address. So you will typically see MAC. Where is it? So you typically see MAC address. MAC address is a layer 2 address. IP address is a layer 3 address. The simple reason is that MAC address is associated with a switch, and a switch is a layer 2 device, right? A switch is a layer 2 device. An IP address is a layer 3 type of address, or a logical address. Why? Because a router is a layer 3 address. So it's a router that can assign IP. A switch will not assign IP. A switch will just forward packets and frames, right? Whereas a router we assign IP. They are all just IP. They're just means of identification, right? A MAC will identify a system. Your phone, if it has 2 SIM, it has 2 MAC addresses. Your laptop, if it has 1 port, it has 1 MAC address. Every device that is going to be connected to either one Wi-Fi, whatever, is going to somehow have a layer 2 address and also have an IP address. So an IP address is just a way for us to say, okay, if we are sending something, that is where it is going to, right? Okay, let me go back. Did I miss anything? Latency. Okay, I think you can write also one more assignment you're going to work on. So I want you to be able to differentiate latency, bandwidth, if I got that spelling correct, bandwidth, throughput, what else again? So I want to get differences, right? You could Google, you could use ChatGPT. And when you get in some of this, understanding some of these concepts, you want to be able to have case studies for them, right? Scenarios for them. It will help you understand the concepts better. Then the last one is the physical layer. Okay. So last thing before we go, let's talk about topologies. So you can't set up a network without understanding how it is made up of. So very simplistic, bus, very old, ring, star, mesh. So star is the most common. So this might be a router. Most of us, if we have a router in the at home, or if it's a small business, just have a router, everybody connect through wireless to it. That's a star topology. For some enterprise network, because of quality of service and because of you not trying to have a single point of failure, you have something that looks like a mesh. So this guy have 3 stuffs connected to it. So if one fails, you have the second one. If this one fails, you have connected to the second one. So these are what you call topology. So your topology is just how you present your network, right? So most of the times you're going to be doing star or mesh. And of course, you have an expansion for each of them. Okay, I think that's a summary for this class. So you could study module 1. And in the next session, we're going to be looking at module, I think, just a moment. Okay, MAC address, how many bits? Who can try? No. Not 8. No Googling, no ChatGPT, no browsing. What's the answer? Francis, MAC address. Okay, MAC address, okay, 48. IP version 4 is how many bits? Some people have gone to the internet. Okay, so MAC address is 48, IP version 4 is 32 bits, IP version 6 is 128 bits. So please have that in your memory. Research more about that. We talked about hub, switch, bridge, router. I gave some assignments, so please, this is the end of class 1.